All right, welcome back to Intro Technology 1023. We're going to be going over power supplies for this one, and it's going to be significantly shorter than the motherboard and GPU and CPU lectures that we've already done up to this point, uh, for the most part. What a power supply is actually doing is taking your AC current and converting it to DC. And the reason why we got to do this is because AC is a much safer technology or way of transferring electrical current over many miles. So your telephone poles that have electrical current going through them, it's much safer to use AC for that rather than DC. However, your electrical components need direct current or DC. So your power supply is there to convert that. So unfortunately for us, and this is changing in the future standards, but for right now, that power supply has to convert to three different voltages. All right, that is 12, 5, and 3.3. So depending on the device that is plugged into the motherboard, it's going to require this particular voltage. Okay. And then depending on which device in particular is requesting that power, it might even have to be converted into something that's much more precise, like a CPU through VRM phases. Okay. So power supplies do not provide current, and this is an important topic, does not provide current. It supplies a request for it. So this gives a potential for to be over requested. So if you put in a underpowered power supply, you have the opportunity to one, break it or break the components that are requesting that power, or two, it's just going to randomly shut off because of the built-in safety precautions that are now part of the ATX standard. Okay. 80 plus standard. So 80 plus originally was there to make sure that things were, well, one, standardized, but two, standardized for efficiency. So depending on which power supply you are getting, more than likely it's going to be gold at this point. There are some bronze out there left, but you don't see the original 80 plus anymore. It's just not around really. Uh, bronze. I don't see silver at all. Gold, platinum, titanium are both kind of top of the line still, and it's going to be very difficult to surpass them because here are all the standards. Okay, so if we're talking about titanium, which is the highest at 10% load, 92% efficient. So when we're talking about power supply efficiency here, we're talking about the amount of power that's going through it, how much is actually converted into DC rather than heat. So at 10% load, only 8% of this is wasted energy. Okay. 50% load is 94, and then 100% load is 90. So if you have noticed, the top end spec here has a bit of a bell curve to it. So relatively low load, a little bit lower, max load, a little bit lower. 50% load is about most efficient. So there is a argument out there that states that you should over allocate your power supply because it's more efficient. At 2%, doesn't overly matter. Okay. Platinum. So the difference between platinum and titanium is very, very little. 2% on the low end and then 2% in the middle, and then the same on the max load. So very, very, very little difference. Okay. And if we actually did the math on that, I'm sure that'd be like $10 per year of a difference. So overall, not that big of a difference. The primary thing that people tend to go for titanium over platinum for is the component themselves, because they'll last a little bit longer because it's a higher spec. But overall, not that big of a deal. Power supply standards. Okay, so ATX is the one that you're probably used to if you have ever built a desktop computer. SFX if you have done anything of the small form factor, and then any servers is going to be U standard, so 1U or 2U. With that said, there are a lot of proprietary power supplies out there that are just found in your pre-builds. They are all unique to the company. So Dell in particular is pretty infamous for this, where all their components are Dell proprietary. Really annoying, but what are you going to do? It's Dell. Okay, selecting a power supply. So here are all the factors that really go into selecting a power supply. Obviously, there's wattage, right? So if you're trying to get a 750 watt power supply, you probably don't want the newest NVIDIA GPU because it's going to almost completely take up that power supply, let alone everything else. Okay, so wattage is important. OCP is the other major factor here. So overcurrent protection, a power supply will provide a little bit of extra current than what is rated for. That's just not good for the system. So it can do micro peaks, which components do that quite a bit. The current NVIDIA GPUs are pretty infamous for this as well. Their typical TDP is something around 200 or 300 watts, and then it will spike up around 600 or 700, depending on what you got. So OCP is there for things like that, where you have your entire system that peaks for power for some reason. It will shut itself down to protect the power supply and the rest of the components for that matter. And the other one that might be a thing for you guys is short circuit protection, but not going to be using that much. You really care about OCP and you care about wattage when you're selecting a power supply. So this video right here, we're not going to go over it because of copyright issues again, but this is a demonstration of OOP failure, or OPP failure, excuse me. And this is through the Gigabyte power supplies, and this was, what, 6 months ago, 7 months ago? Wasn't pretty recent, but this is a pretty good demonstration of what that looks like when it doesn't work. Again, I'm not going to go over this. Here's another video that goes through the power supply connector types. In particular, what this is going over is the fact that there is no standard for these. The ATX standard only determines that there's 8 pins or 24 pin or Molex or PCIe. In terms of where those pins end up going to on the power supply side, very, very different, and they can be changed. They are different between the companies. So a Corsair power supply is probably not going to work with Seasonic provides Corsair. Well, even that is probably going to be different. So difference between Corsair and Seasonic or Lipa, something along those lines. Those power supply cables are different. So if you are building a custom PC, make sure you know what power supplies go to what, because it's not obvious. Corsair is trying to make a standard. They call them Type 4 at the moment. Corsair is trying to make a standard for power supply cables, which is nice. Okay. Same thing with this. This video is going to go over in much more detail, much more like electrical engineering standards of what the power supply is actually doing, just outside of my scope, and they can explain it better than I can.
Why did you?
Okay, so that is the presentation for this particular topic. All right, we still have a handful more to go through for actual CPU or not CPU hardware, but computer hardware in general. And yeah, we're turning the corner on this topic though. So there's a handful of topics still to cover, particularly RAM is going to be the important one. But other than that, that's all I got for this one, and I will see you on the next video.